Today we'll talk about a lab about Cisco TAC with F5 ServiceCenter. The F5 ACI Service Center platform runs in Cisco APIC, providing an administrator a unified way to manage both L2, L3, and L4 S7 infrastructure. The application offers enhanced ACI to Big IP visibility, L2, L3 network management capability, and L4, L7 application services to ACI workloads. The F5 ACI Service Center enables the visibility, L2, L3 stitching, and L4, L7 app service between Big IP and Cisco APIC ACI. So by using a F5 ACI Service Center app available from Cisco DC App Center, I can add, manage it, and log into multiple Big IP systems. The Service Center provides features like visibility. We can provide to view Big IP network elements like VLAN, VIPs, and nodes, and correlate them with APIC information like tenant, app, EPG. L2L stitching facilitates L2, L3 stitching between APIC logical device and the Big IP for VLAN, self-IP, default gateway. L4, S7 app services create customer application definitions with help of a declarative information. I will go into detail on each of these use cases in sections to come and discuss and value it as to my L2, L7 integration and solution. I will review the configuration of APIC and L4, L7 constructs I must configure as pre-configuration. Two tenants are configured, AX and SJC. Each tenant has following configurations. First, it has VRF and two bridge domains, one representing customer bridge domain and the other representing the provider bridge domain. Two endpoint groups, one represents client, consumer EPG, and other representing the provider service EPG. Application profile contains both EPG. Into the EPG, VNM integration is completed, and VNM domain has been assigned to the EPGs. A static endpoint entry of a WIP, virtual server, and consumer client EPG is to mimic the VIP entry learned by APIC. For next, we'll configure L4, S7. The value is we are going to configure our two-arm service graph to connect a F5 Big IP to APIC fabric. ACI technology enables me to insert L4 to L7 functions using a concept that is called service graph. This lab will describe the service graph concept and how to design for service insertion using the service graph. With service graph, ACI introduces innovations at both data plan and management levels. Using service graph, Cisco ACI can redirect traffic between security zones to firewall or a load balance without configuring firewall or load balancer as default gateway for the servers. ACI can selectively send traffic to L4, L7 device based, for instance, on protocol and L4 ports. Service graph redirector offers many advantages. It eliminates need to make firewall or load balancer the default gateway. and it avoids the need for more complex types of designs such as virtual routing via forwarding VIF, instance L4, L7 VIF design. And it avoids the need to split the L2 domains, the bridge domains, to insert, for instance, the firewall in a path. And it lets me redirect only a subnet of traffic based on protocol and ports. It allows me filter traffic between security zones in the same L2 domain's bridge domain. And it lets me scale performance of L4, L7 device by distributing traffic to multiple devices. And there are different F5 deployment options, and the one we are covering in this lab is 2-arm deployment model. So there's some highlights of 2-arm deployment methods. So we have more than one interface of F5 load balancer is used in the methods of deployment. One interface and one interface. For physical servers, default gateway is the F5 load balancer IP. And asymmetric routing does not occur in this method. The client source IP will stay intact. So let's say client IP is retained. We will begin the configuration of L4, L7 structure in APIC. So first, a device cluster is known as a logic device is one or more concrete devices that act as a single device. A device cluster has a cluster or logic interfaces which describe interface information for the device cluster. This app I will create the big IP manage the L4, L7 device under tenants, indicating big IP virtual addition device we are going to use, as well as the interface association. In the tenants menu, we'll click the LAX tenant, and we'll expand the service, find L4, L7, and then we'll click the device. We'll right click and then select the create L4, L7 devices. The device name, big IP VE standard alone. Device type is ADC, 1 meg virtual. The virtual center VIM domain, it's my vCenter, and the contents where the single function type is go to. Click the plus sign at the top right side and in the device section, and we'll create the device 1. The VM, we're going to select the BIP1 virtual machine. The interface we're going to create is we'll call it external. The VNIC we'll use network adapter 2. Then let's create an interface internal. VNIC we're gonna pick is network adapter 3. Click the OK. So back to this diagram, the internal gonna be VNIC 3 and external VNIC 2. We have VNIC 1 is gonna be management. So VNIC adapt 2 as defined used for the external or we call it the client side. On the VNIC network adapter 3 as defined is used for the internals, the server traffic. Go back to the epic and we add the cluster interface. The first cluster interface is external, and the interface we're gonna pick the external. Click update. Click the plus sign again and add another cluster interface. We'll add the internal. Gonna pick the internal interface we defined previously. After all that, click submit. Now we have a device for L4 and 7. The next thing we'll talk about is service graph templates. A service graph template represents that two or more tiers of application with appropriate service function inserted between the tiers. We'll create two ARM service graph templates with F5 big IP in middle of service chain. So in the menu, expand the LAX service L4, L7 and right click the service graph template, then we'll create L4, L7 service graph template. And we'll drag and drop in between the EPG, provider's consumer. Give a name for the service graph is going to be 2ARM template. Pick 2ARM for ADC and click submit. Now that the service graph is created, I will apply and deploy the service graph template with some parameters. First, the consumer EPG and provider EPG. The new contract is created for a big IP VE standalone contract. So expand the service graph and right click the 2ARM template. Select apply L47 service graph template. The group type will remain EPG. The consumer EPG will be the LAX, the APN, EPG consumer EPG. The same for provider, finds the provider EPG. A contract we're going to create is a new contract. It's going to be big IP, VE, standard, alone contract. By default, it has a new feature, allow all traffic. Click next. In the consumer connector section, in the cluster interface fields, we're going to select external. Then in the provider connector section, in the cluster interface fields, we're going to select the internal. Then we'll click finished. Look at the configuration I got pushed once the service graph was applied. So in the menu, we're going to expand the developer's graph instance. We'll click the deploy graph instances. A deploy graph displays which is the applied state. We're going to expand the deploy graph instance. Click function node N1. In the property section, scroll down to the function connectors. we're going to see the in cap for consumer and provider VLAN are assigned. The VLAN IC might be different. UC might be different here, consumer and provider. The next thing we're going to do is to cover different use cases by the application. So we're going through the lab. Think of myself as a network administrator, so who along with managing the network is also looking to expand my skills in applying those network operations practices for supporting DevOps. So the big IP being used in this lab is virtual edition that is integrated with APIC through the VM domain. So we're going to add a big IP device that we're going to manage using the application. So we're going to log on to the F5 ACI Service Center. The APIC used here is a simulator, and an ACI app cannot be loaded on the simulator. So in the lab where there is a physical APIC, is a standalone cluster, the F5 ACI Service Center will be present as a software image that is uploaded to the APIC. And lab environment, we're using an APIC simulator. So F5 ACI Service Center will be accessed from outside of the APIC. So big IP devices that need to be managed by the app will have to be added to the app. So the APIC has no information about what the IP or the credentials that are for the big IP. If I remember, we're configuring the service graph, so all I mentioned is the physical connectivity and not the credentials. So in the new device, so I enter the big IP device credential and click the log on. So in the end, we'll see device hostname, random state, and configuration state is displayed at the top of the page. Along the three tabs: visibility, L2, L3 management, L4, L7 app services. Next, I'll create the VLANs and self IPs. So the big IP is to complete the lab configuration using a logic device cluster we created earlier in the APIC. So let's create the VLAN and self IP. So the previous section we deployed the service graph and noticed that the dynamic VLAN assigned to the service graph. These are the same VLANs we configured on the big IP to achieve network stitching. To click the L2, L3 network management, the logic device list, we're going to select the VE standalone big IP. Choose the to click the S sign. We'll see read-only APIC information. So this information includes tenants, concrete devices interface, and device type, physical, virtual. Yeah, this is virtual. And we're gonna see a list of VLANs configured in a available box in the APIC device selection. We'll select VLANs and move them into the selected box. Click Manage Selected to the bottom. So one of the interfaces is external and the other is internal. VLAN configure form is displayed to add VLANs and the information for one or more self IP. So for VLAN, the fields to be configured are the tag in the interface. The self IP, the field to be configured are the address, the network, net mask, traffic group, port, logname. So whether the interface is tagged or untagged depends on its device type. For the physical device, the VLANs are tagged, and the virtual device, the VLANs are untagged. This option isn't configurable in this lab because we are using the virtual device. The interface will be untagged. So the VLAN will also display if it is the internal, external interface which is relevant to what interface I assign on the big IP. So in the configure VLAN for logic interface, in external, we're going to do a few things. So we do not change the VLAN tag. Here will remain 1170, and we're gonna select interface 1.1 uninitialized. So and we're gonna click assign self IP. The self IP we're gonna make is 10.10.10.50 net mask /24. The traffic group we're gonna pick the traffic local only, and the port we'll say allowed or allow default. For the internal dialog, do not change the VLAN as auto assigned. I'll click interface 1.2, assign it as self IP 10.193.150/24. Same group, same port lockdown, allow default, and let's click submit. So the big IP device has the same VLANs configured as the APIC, LDEV VLAN, and L2L3 stitching is complete, and F5 ACI Service Center is stated for application. All network information is now stored in the application. Deleting and modifying the configuration can be done using this app. So let's take a view of the VLAN and self IP configuration on the big IP. We're going to navigate to the network, VLANs. Here we're showing available VLANs which is configured. You can go to self IP. The IPs were configured. So now this time our network stitching is complete. We have clipboard with service graph on the APIC and have assigned corresponding network on the big IP. Let's return to the F5 ACI Service Center application tab. We're going to go visibility tab. The contents of all tables are populated by pulling information from the big IP, then correlating it to configuration on the APIC. So F5 Service Center partition list, the common partition is selected by default. If any other partition is selected, for example, the sample partition selected, the table show entries to belong to the both sample partition and the common partition. So we're going to view the VLAN table. In the table list, the VLAN table is selected by default. The table shows all VLAN in caps from big IP device that have a correlated logic device antenna entry on the APIC. Let's view the VIP table. The current table is empty since we have not configured any VIP pool members on the big IP. The table will pull virtual servers, the pools, and the pool members from big IP. Also displays the correlated information from APIC if VIP is learned by the APIC. So let's also take a look at the node table. Current table is empty since we have not configured any WIPs pool members on the big IP also. So the table shows all nodes from the big IP device provided they have correlated the tenant, application, and EPG entry on the epic. It also displays the pools that the node belongs to. For each pool, it shows correlated VIP, so all via virtual servers. So this time we're going to configure application on the big IP. We'll configure some VIPs and pools the nodes on the big IP and see how they are reflected in the visibility tables. We'll create the partition and the application using the basic mode. We'll click the L4, L7 application services. We'll click application tab and then application sub tab and select the basic mode, and in the partition list we'll click create new partition. The template drop down, we're going to pick the big IP fast template for HTTP. A table will show up here. So the tenant name, we're gonna make is demo partition. The tenant is the high level group in AS3 declaration. So fast deploys all configuration for given tenants in a big IP partition of the same name. So application demo application virtual server IP 10.10.10.100, port are going to be 80. We're going to give some pool name in the pool member. We're finding the server address 10.193.112. and click add. Next one 10.193.103. The ports will remain 80 share nodes. We'll uncheck it. Load balance method. We're going to use the runs Robin. Let's leave all other fields in the default setting. And by the way, we're going to uncheck HTTP redirect. You have is the virtual servers IP round robin port number 80. We're going to submit table. So the big IP has processed and pending task. We're going to take a look at the big IP. Now the partition has been added. The one is demo partition. Navigate to local traffic and virtual servers. We're going to click the we'll pick the demo partition, virtual server, and finding the demo application. We'll scroll down and view the configuration for the virtual servers. Some will pass the parameters to be preloads, others that were treated as default. We'll go up and click the resources. Then we're going to navigate to local traffic pools and pool list. Click member. Member are saying the two servers are configured. Return to F5 and we're going to delete application and partition using the basic mode. In the application, demo application, click delete. the application is deleted from a big IP device and it won't be listed in the application list. Go to big IP. In the big IP tab, when we verify the partition, demo partition was deleted from the partition job list. Let's return to F5 ACI Service Center. I'll click L4 S7 Application Services and I'll click the application. This time we're going to choose the advanced. The partition, we're going to still create a new partition. It's going to be demo partition. The application will say demo application. Here we're seeing the sample code with some of the options. The WIP IP, we're going to say 10.10.10.100. Scroll a little bit down here, we'll find the server address, same server address. The service port remains at 80. Go down. Looks everything the sample codes are good with the replaced IPs. Click submit. Back to the epic. So now a new partition is created again and applications are created on the big IP device. Let's take a look at visibility. Let's move on to the notes information. Also choose the partition to be demo partition. Now I'm saying only one pool member is present. So even though we added 2 members, only those nodes that Epic Fabric Learn display. So the pool member workload is present to provide the EPG. We're going to return to the Epic. We're going to go tenant, LAX tenant. And in the tenant, we're going to navigate to application profile, EPG, and we're going to find the provider EPG. In the provider EPG, click provider operational. Only one member is learned, which matches the 10.193.1102 from visibility tab of F5 ACI Service Center. So to make Epic learn the second endpoint using automation on the desktop, we'll click the Postman, then we're going to close the intro pop-up and the pop-up, and then both will display. Then we're going to go to dismiss and collection. We're going to click endpoint management. We're going to select Epic logon and click send. This is going to create a logon token for the API call. So we're going to select as endpoint Alex and click the body. Confirm. We're going to confirm the body, the token. And then we're going to click send. Go back to the Epic. Click it again.
Now return to F5 ACI Service Center.
Click on visibility. I'm seeing as
The two nodes are displayed.
also click on whip.
This table will pull the virtual centers and pools and pool members, then the whip permissions displayed. What we next to do is managing L2, L3 configuration. Note that I have performed some day 0 configuration for networking and also the application. I will look at how I can manage the day end configuration using F5 ACI Service Center. For this step, I assume someone from my team with access to the APIC redeploys the service graph that has been stitched to the IP without understanding the impact. So I would use the application to help rectify the issue. So we'll first redeploy the service graph. So in APIC we'll log on, and in the tenant we'll click the LAX. We'll find the contract. The contract we're going to define is a standard, and we'll find this contract that was first configured. Go to subject, scroll to the bottom and find the L4 L7 service graph parameter, and then we'll hover over the fields and then we'll click the clear icon to clear, and we're gonna submit the changes. Now we'll go to the L services. We find it is the L4 L7 deployed graph instance. Now it has no graph service graph deployed. So then we'll now go back to the contract, find the contract and the subject. Let's go ahead and reassign to ARM template, submit it, go to service, find back to the developed graph instance. Now we can find the service, go to the two arms service template, then go to the function nodes N1. In F5 ACI Service Center, we'll notice that the VLAN table still has no information since the VLAN on the APIC has changed. There's no way for application to call relate to VLAN anymore since those VLAN still do not exist anymore on the APIC. Well, then click I2 L3 network management. We're gonna select is the LAX big IP VX standalone for the logic device cluster, and we're going to reassign it. Go over to the warning sign, each of the VLAN here. We'll notice the VLAN and the corresponding numbers. We'll click the manage and select it, and click continue on the pop-up. It's the same thing. We're going to change the VLAN and refactor a new VLAN in the form, and click submit external. the internal.
Then we'll click submit.
The app string has helped me see the configuration discrepancies and provided I will an interface to fix the discrepancy without logging directly into the big IP. I can view the VLAN table under visibility and see both entries now. Also log on to the big IP and view the VLAN change. Then next we'll modify the big IP configuration, our OOB. Log on to the big IP and we'll go to common partition and we'll navigate to the network, go to VLANs and update the tag value to any tag between 1001 and 1010. Then we'll go to click one of the VLAN here. What I'm gonna do is to 1005, and we're gonna to click the update. We're gonna return to the ACI service center. I will click visibility again. Refresh it again, and in the VLAN table there's only one entry because the VLAN on the big IP has changed, and that VLAN does not exist on the APIC, so there's no correlation anymore. So we're gonna to do the L2L3 management, and in the logic device cluster we're gonna to keep using this lax, this only one, and used arrow to move the new VLAN from available to select. And that's the time I will tell you something. Here you want to notice the far right here listing is an auto sync notification for the VLAN. Click auto sync link. Okay. The system will present two sync configuration options: to sync based on the information from a big IP or based on the information on the application. What we're going to choose to sync to the big IP is this button. The application reverts to the VLAN tag back to the original and solves the auto sync issue. We'll select visibility. And I'm going to view the VLAN table. Log back into the big IP, and we'll go to network in VLAN same place. I'm seeing the VLAN change has been made. And next, let's talk about the dynamic endpoint attach detach. This feature supports dynamically updates endpoints on big IP pools, and whenever endpoint gets attached and detached from APIC EPGs, the F5 ACI ServiceCenter application provides a way to create the map between APIC EPG and big IP AS3 application. We do not support both static and dynamic pool members. So I will add either server address, a static member, or endpoint mapping, a dynamic member, but not both. In this app, I will delete the application with the static members created from the previous app, and then configure dynamic endpoints mapping. Let's delete the application and the partition using an advanced mode. Return to the F5 ACI Service Center, and we'll click the L4, L3 app services. In the application subtab, we're going to select the advanced, and in the partition here, we're going to click demo partition, application, will be demo application. We'll click delete icon next to the application list from prompt, and we're gonna say delete. So the results comes like the application is deleted from Big IP's device and won't be listed in the advanced application list. Because demo application in the last application in the demo partition, the partition is deleted. Log on back to F5 to verify that. Now, we should go to application, subtab again, and we'll select the basic mode. In partition, we'll create a new partition. And for the template, we're going to select the service discover HTTP. We'll click upload to install template on the Big IP. Once the install process is completed, we're going to select the service discover template again. Then you will see a form is displayed, and to verify the service template is installed successfully, we'll log on to Big IP. I will select the iApps. In iApps, we're gonna to find the templates. We're going to application service application. Application LX. We should find the templates. Scroll down. Now I have HTTP application templates defined. Go back to the service center, and we're going to say the tenants demo partition. Application name is demo application. The service tenants locks service discover APIC disk application profile. We're gonna make sure the EPG is provider EPG. We'll find the service discover APIC endpoint group is provider EPG. Yeah, scroll down to find the virtual server IP address. Still gonna be 10.10.10.100 port 80. We'll uncheck HTTP redirect. If we can find the row balance for round robin, we'll leave all other fields with default settings, and we'll do a submit. Let's view the current configuration on the Big IP. We'll go to Big IP and local traffic. Then we're going to demo application pool. First, we're going to use the partition. Click into it, select the member. This pool member will collect it from APIC APG and deploy it on a Big IP as pool member. This time, EPG has two endpoints, learns which got configured on big IP. I will trigger more endpoints to be learned and verify that they automatically get deployed on big IP. We will also trigger deletion of endpoints from a epic EPG. We're gonna go to Postman to steal the collections, and we're gonna add endpoint Alex and the good body here, and make sure we have this body content, and we're gonna send. Make sure we're going to add 4 Ethernet, and I'm going to do 5, 6, 7, 8 Ethernet 1/9, and now we're going to return to the APIC. And we're gonna steal the tenant Lax application profile to the Lax APN, and we're going to provide an EPG operational. We're gonna verify all endpoints are displayed here. I'll return to the big IP. Click again the demo pool. And I'm going to select the members. The members tab to display pool members or verify new endpoints that have been added to the pool dynamically. So we'll return to the service center here. I'll click the visibility, and in the tab list I'll select the VIP information later. The table will pull virtual servers pool members from big IP, and it also shows all correlate information for APIC if a VIP is learned by the APIC. Next, we're going to see the AS3 application, the application inventory. In the L4, L7 application services, we'll find application inventory tab, and it will show a list of the AS3 applications present on a big IP device. We're going to click the SD view EPs. So they're going to show us the endpoints present in the service directory endpoint of big IP. Okay, and we're going to sync EPs, so they will retrieve all endpoints from associated tenant application EPGs and create them in the associated pool of the application. So the sync endpoint icon is an option that can be used to manually sync the endpoints from an associated APIC, the tenant application EPGs to the big IP pool. If for some reason the endpoints on the APIC and the big IP pool members that are not in sync, use the Postman. I'm going to delete endpoints. Go to body. We're deleting 1/9 sent, and more to the 8, 7, 6, 5, 4, and then let's return to the APIC. Then I'm gonna go to the tenant. Still the provider EPG. Go to operation. I can only see 2 now, while 6 endpoints have been deleted. I'll return the big IP, then go to the pool members, and we're gonna refresh the list. Now I only see 2. 6 have been deleted. This is removed, and go to the visibility on the service center, and I'm going to seeing only 2 endpoints left. Let's view some app faults. Return to the remaining on the service center. We're going to F5 ServiceCenter. In the application tab, we're going to make it advanced. In the partition, choose demo partition, which is created. Application will create a new. This time we're gonna make a new test application, but we do not provide a VIP or pool member to prevent the modification of the AS3. Let's go ahead, go to submit. Okay, let's go ahead, go to future and visibility, or that's visibility. See the warning sign here. I show a data grid with 100 errors warnings. Happens in the application background task, and also I show any resolution. We're gonna double click the fault line here. So the window will show the error in the details. Next, we'll just talk about the one-arm service graph. So the previous lab went through the process of creating two-arm graph on the APIC, representing a two-arm development model on F5 load balancer. So this time we'll discuss the differences between one and two-arm deployment model. In two-arm methods, we use more than one interface of F5 load balancer in this method for deployment. For physical servers, is the default gateway to F5 load balancer IP address. This asymmetric routing does not happen in this method, meaning actually it doesn't have the other default gateway for different routing, and the client IP is retained. However, in the one-arm method, there's only one interface in the F5 load balancer that's used in this one-arm method of deployment. For the workload, the default gateway is not the F5 load balancer IP address, but it is the ACI fabric. Therefore, source address translation SNAT is needed to be configured on the F5 to avoid asymmetrical routing. So the client IP is not retained. Instead, we'll change to F5's IP. So there are ways of retaining the client IP. That's the topic out of scope. We'll talk about later. If you like, you can watch about my F5 videos. This lab, we're going to look at one ARM configuration option, as we have already covered the two ARM option. So imagine an example where the consumer EPG and provider EPG and F5 EPG are all in separate bridge domains. So we are going to have a consumer EPG and two consumer bridge domain. And a provider EPG to a provider bridge domain.
Go to APIC. Still, in the tenant blocks, we'll expand the services L4 and L7. We'll find the device. We'll create a new device L4, L4, and L7. This time the big IP VE say 1 stand alone. It's virtual and virtual machine. Single and go to. We'll click add plus sign to add a device. So device 1. Same thing, choose the device and the VM. Make external interface. Or pick adapter 2. Update. And click OK. We'll click custom interface. We'll also make external. Did it so. We only have one interface to select. Click update. Submit. Now we're okay to create a service graph. Create a service graph template, dropping the one arm. In this case, the service graph name will become one arm template. ADC, which is one arm. Click submit. Then we're going to apply the service graph. We're going to create a consumer, provider, and a new contract. So go to service template still, find one arm, and apply. The consumer EPG is gonna be a consumer EPG. Provider is the same. Provider contract will make his new contract be big IP B1 standard alone contract, and we'll go next. Custom interface will make it external. Click finish. Let's go to the deploy service graph, and we're going to see one arm template is applied. Continue to expand one arm, find function nodes M1. In here, the property has been assigned to the VLANs. Notice the VLANs are the same because they're all on the external interface. Then we'll go to one arm configuration, big IP. Because we are only using one interface on the big IP, define the following will be applied to ACI F5 ServiceCenter. We'll define one VLAN that matches the VLAN allocated by APIC when the service graph is deployed, and one service IP belongs to the subnet range associated to F5 bridge domain, and a default route to point the default gateway of subnet assigned to the F5 bridge domain. So that's all about the one arm model. So to summarize the lab, we applied epic config, and we configured the applications on the big IP, and we did a bit of troubleshooting on the visibility, and then we managed the L2, L3 configuration. I dynamically attached endpoints and detached endpoints. Then lastly, we talk about a little bit of F5 one-arm service graph. That's concludes all about this lab. If you like my video, please click the like button or subscribe my channel. Thank you.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget